If we talk about instance variables, static binding only uses type information. So we'll use, when we declare instance variables with whatever the type of that variable is, that will be checked by the compiler and allowed if we are trying to use the variables in that same context. Access to field is governed by the type of the reference. For example, we have a class base and that has a variable x with a value assigned to it. Then we have a class derived that extends the base class with one of its own variables y that has been assigned a value 20. Case 1, for example, we have an object b1 with the derived reference. And if we try to, for example, print these values, b1.x, it should print the value of the x variable x from the superclass, and b1.y should print the value of the instance variable y that has been declared in the subclass. So it has inherited this variable x from the superclass and it prints the output, and it has its own variable y and it will print the output of this variable as it is, because we have declared the variable or the object with the derived class reference. But in a different situation where a derived object is declared with the superclass reference, for example, here we have this object b2 and we have declared this object with the superclass reference, that is in our case named as base class. Now if we try to access the variable that has been defined in the subclass, compiler should not allow us to do that. The instance variable is inherited from the base class. X can be accessed by the object that has been initialized with the superclass reference, but the variable that has been declared explicitly or exclusively in the subclass, there is no y declared in the base class. It will give us a compilation error. The idea is that when we use the superclass as reference to initialize an object of the subclass, we will not be able to access the methods or instance variables that have been declared in the subclass with the superclass reference. This is something that we need to keep in mind when we are using polymorphism or we are using the superclass reference to initialize objects of our subclasses. Now let's look at a situation where we have two variables of the same name and we said that static binding only uses type information. Access to fields is governed by the type of the reference, as we saw in our previous slide as well. So for example, we have a class base2 that has a variable integer x is equal to 10, and we have a class derived 2 that extends the base2 class with the exactly same variable integer x that is initialized to a different value. And we'll see here we have two variables with the same name in these two classes. This is the derived class and this is the superclass. A field that has the same name as the field in the superclass hides the superclass's field. So what should happen is, for example, when we declare an object of this subclass using a reference of the subclass, if we try to print the value of x, this is the value that should be printed, and this is the variable that will be hidden by this variable or this object of the subclass. So this value will not be printed, and this will be printed by the object of this subclass. In the other case, where a derived object is initialized using the superclass reference, here in this case what should happen is, for example, b2 is declared as type base, as we can see, then it will print the value of the variable in the superclass, and this variable x is equal to 20 will be hidden. The reason for that is The superclass cannot have access to the variables or methods in the subclass. That is why the instance variable x from the base class will be printed, and the one that has been initialized with the derived class, it will hide the superclass's variable. This is something that we need to keep in mind, that if, if we declare an object with the subclass reference with its own reference, then it will hide a variable of the same name from the superclass. It will only access this variable from the subclass. But since we understand that we cannot access the variables or method of the subclass from the superclass reference, then in this second case, the variable from the superclass will be accessed and the value of x is equal to 10 will be printed. Now, how can we get the hiding of values? Within the subclass, the field in the superclass cannot be referenced by its simple name. Now, what we can do to unshadow this? How will we try to access the superclass's variable? For example, if we have two variables with the same name as we saw in the previous slide, and we want to access the superclass's variable explicitly, then we can use the super keyword as we have been using in the previous examples, that when we had a method toString in the superclass as well as in the subclass, then if we wanted to access the method of the superclass, toString method of the superclass, we used super.toString. Similarly, we can do it with the variables. When we have variables with the same name in our superclass and in the subclass, and we saw that the variable of the subclass overshadows the variable of the superclass in our previous slide. But if we want to access our variable from the superclass, so that we can do is we can use the super keyword. So now we have a class derived that extends the base class, and if you want to print the value of the variable that has been declared in the subclass as well of the variable x declared in the superclass, this is how we can do this. X from the derived class, that will be accessed directly, and then x from the superclass, that will be accessed with the help of the super keyword. So this is how we can unshadow or access the variable from the superclass. This dot access the field name x defined in the child class. As we have been using this keyword, and we understand that this keyword refers to the variable name that is exactly in the same class. So this dot x will, if we use this dot x over here, this will mean that x variable x of this class in whatever class that has been used. On the other hand, super.x access the field name x defined in the parent class. Super.x is not valid. We cannot, for example, access a variable super in the super class by using this super.x. It will not give us a value of the super class. And we saw that we need to keep in mind that x was not specified as private, s was a public variable. That is why we were able to access that variable in our subclasses. Static variable, static binding only uses type information, as we have been seeing. Access to fields is governed by the type of the reference class variable, and by class variable we mean that a variable that has been declared as static, and we have discussed the static variable previously as well. A class variable or a variable that has been declared as static has one copy only that is accessible to all the instances of the class. All instances of the class share the same static variable. That means all the objects of the class will have exactly the same value for the static variable of the class. So we have class base3 that has a public static integer variable x is equal to 10. Then if we have another class, public class derived extends base3 with its own static variable y, Invoke the static variable in base3 class, invoke the static variable in derived 3 class with the help of these statements. So for example, if we try to print the variable x of the base3 class, and we understand that we can access the static variables with the names of the classes. We do not need to declare an object for the base3 class to be able to access the static variables or the static methods of the class. And that is why we have been declaring our main method as static, because that is the first method that is accessed whenever we run the program, our program. And since when we run the program, there has been no objects have been declared, and we want to access our main method without declaring any object. So when we declare our variables as static, we can access those variables without the objects, directly with the names of the classes. And this is the output which we should get. For example, in this case, we are trying to access the variable of the superclass with the name of the superclass. It will give us this value. We are accessing the variable of the subclass with the subclass's name. It will guess the value of that variable, and this should work the same because we are inheriting that class. Then, for example, since we are printing the value of derived 3.x, this should be y and this should be x. So we are accessing the value of the superclass's variable directly with the name of the class. Even if that is an inherited by a subclass's name, we can access this value that has been declared as static. And we can see that both of these variables have only one copy, even though when we access the superclass variable with the subclass, you are able to get exactly the same value because of the static keyword that we have used. So a static variable or class variable will have exactly one value or one copy of the value for all the objects of that class or even the subclasses objects. Private final and static methods. A final method in a superclass cannot be overridden in a subclass. We have talked about this earlier, that if we want to prevent a subclass from overriding a method of the superclass, then we can declare that method as final. Methods that are declared private are implicitly final because it's not possible to override them in a subclass. When we declare a method as private, then we obviously cannot access that method in the subclass, and that method is by default or implicitly final. That is why it cannot be overridden in a subclass. Methods that are declared as static are implicitly final. So if we declare a method as static, and we look at a few examples as well to understand these ideas, then we cannot override that method as well. And by that we mean a final method's declaration can never change. So all subclasses use the same method implementation, and that is the implementation that has been already done in the superclass. And calls to final methods are resolved at compile time. We all know in advance that which method will be executed when we call that method, because that method has not been and cannot be overridden into the subclasses. This is known as static binding. So in simple terms, when we know in advance that which method will be called during the runtime, then this is static binding. But when we do not know the output of a class or the message call or the message that will be sent until unless we run the program, that is dynamic binding. Static methods. To look at the static methods example, for example, only the non-static methods of a class can be overridden. We have been talking about this point repeatedly. So we have a class base4 that has a static integer variable, and we can see that that variable is declared as public equal to 10, and that class has a static void get method as well. We have a derived class that is derived from the base4 class, with the static variable and the static method with the same name. Invoke the static method in the base 4 class, invoke the static method in the derived 4 class. If we run this, the output that we should get is for the exact methods that are for the respective methods of their own classes, and all because of the static keyword. And you can check the effect of this static keyword. If you remove the static keyword from here in this super class and try to run the same example again, we'll see what this difference between the static and using the static keyword and not using the static keyword. Private methods. When you declare a method in a Java class, you can allow or disallow other classes and object to call that method. And we can disallow other classes to access that method is by declaring that method is private. Again, with the same example, we have the two methods with the same name in the two classes, but it cannot override this method from the superclass because that method has been declared as private. And if you run this program, the output that you should get is only the subclasses get method, because it cannot access the superclasses get method in this case. Final methods. You use the final keyword in a method declaration to indicate that the method cannot be overridden by the subclasses. So for example, if we do not want to allow a subclass to override the method of the superclass, we can declare that method is final. Again, in our example, here we have the final method void get, and if we try to implement that method, if we try to override that method in our subclass, we will get a compilation error. And the error states that get in derived cannot override get in base 6. That is the base class or the superclass that is defining that method, but it has prohibited the subclasses from overriding this method. So when we try to do this, this will not be allowed. And we look at method overloading, where overloading methods, the practice of defining two or more methods within the same class that share the same name but have different signatures is called overloading methods. Now in method overriding, we have been saying that we have the methods with the same name and with the same signatures in two different classes that are related by the inheritance. In overloading, for example, if you remember from our constructor overloading examples, that we have constructors with exactly the same name but with different number of parameters. The number of parameters or the types of its parameters. The signature of a method is comprised of its name, its parameter types, and the order of its parameters. So if we change the number of parameters in a method, or the order of those parameters, or the data types of those parameters, those methods will become two different methods even though if they have the same name. The signature of a method is not comprised of its return type nor its visibility. So it does not matter, the access modifier and the return type of the method are not part of the signature of the methods. It's only the name of the methods, the method, and the number of parameters inside that method. That is called the signature of the method. So for example, in this class we have two methods, a method and another method, a method with different number of parameters. This has 0 parameters and this has 1 parameter. And this is static binding because when we call this method, let's say we have declared an object of this class, and we call this method and we pass a value to that method. That means we are passing an argument, and this value of this argument will be assigned to this parameter. Then we are explicitly telling the compiler that we are calling this method. There is no confusion for the compiler in this case. So this is static binding. And if we wanted to call this method, we would remove this argument from the calling statement, and the compiler will know in advance that this is the method that will be called. And in this case, it calls the method with the one parameter, and it will not call the method with zero parameters. And this is static binding, because the compiler knows in advance which method to call and which method not to call. If you look at an example of dynamic binding refers to the case where compiler is not able to resolve the call and the binding is done at runtime only. So in dynamic binding, when we are calling a method, maybe for example, we do not know in advance which method will be called. That is dynamic binding, and that is a situation that arises when we use polymorphism. Java compiler can't be sure of what type of object this reference would be pointing to at a runtime. In polymorphism in Java is resolved during runtime when actual object is available. And if you remember from polymorphism, in polymorphism the output of the class changes at runtime based on the calling object, where we were able to declare objects of our subclasses with the superclasses reference, and then we were calling exactly the same method with those objects of the superclasses reference, and we were getting different outputs based on the calling object. And that is dynamic binding. For example, we have a class base8 with the method void g that has a print statement, and we have exactly the same method with the same name in our derived class that is extending the base class. In our first case, a derived object with the derived reference. For example, we have object p1, that is an object of the derived class, and we are declaring it with the derived class's reference. When we call the get method with this object, we know that this is the method that should be called, and this is the output that you should be getting. For example, g in derived and invoke g in derived, because we are using the subclass's reference. But a derived object with a base or superclass's reference, in this case we are declaring an object of the subclass with the superclass's reference. And when we call the same get method with the object, then we will get again the same result, because even though we are using the base class method base class is a reference to declare this object, it will invoke the method in the subclass because we are using object of the subclass. And this was a situation we saw when we had multiple subclasses of the superclass, and based on this object we were able to call the methods of each of those superclass at runtime depending upon the object of the class. That is, even though defined with the superclass reference, will access the method in our subclass.